All right, I'm here with Parker Phinney, the founder of InterviewCake, and I'd love to just have a conversation with you, Parker, about all the world of job interviewing, because we have so many students who have gone to the coding boot camp, have used InterviewCake, and just kind of get a sense of what you think helps and doesn't help in the job search process.
Yeah, definitely. Well, for people who come out of coding boot camps in particular, I would say one of the biggest things to keep an eye on is really focusing on data structures and algorithms.
Okay.
It's something that some schools cover less than others. But in particular, it's something that I think that because it's a whole new area, people think that they can sidestep it, or they sort of hope that they can sidestep it.
Okay.
When I work with candidates, a lot of the times I get the question, okay, I kind of get this big O notation stuff, but is this really going to come up in the interview? And the answer is it may not, but it's very likely to.
Okay, so I definitely want to dive into big notation because that's supposed to drive. But I'm curious if you can kind of let people know what gave you the idea for InterviewCake, and maybe we can talk about what InterviewCake is. We can show a little bit of it.
Yeah, definitely. So the story is that I had a good friend who had fallen on hard times. She lost her job. She was looking to make a career change, and she did a code school, full stack. And at the end of the program, she was getting ready to do interviews, and I wanted to help her out. And so I looked at the other resources that were out there to prepare for coding interviews, and I realized none of them were going to really be as good as sitting down with me for a few hours and running some practice problems.
What were the things that were even kind of in the air back then? This is a couple of years ago, right?
Yeah.
What were the things that you were looking at then?
Yeah, there's the book, Cracking the Coding Interview,
okay.
Which is quite good. There are a number of websites that can be okay. The thing that's tricky about those websites is most of them are basically question databases. That makes sense. I have a bunch of practice questions. A lot of them have neat features where you can try the question right there on the website. But what they're missing is if there are things that you don't know yet, if you're weak on data structures and algorithms, for example, they don't teach you that stuff. They just give you an opportunity to practice it.
Okay.
And so that was kind of the core insight behind InterviewCake was let's build a website that not only gives you practice, but actually teaches the stuff as you go. And
so your friend didn't have any kind of idea about data structures and algorithms coming out of this coding school?
So she did, but she definitely had some gaps in her knowledge.
Okay.
And it's interesting, this is something I see a lot. I see a lot of folks who have heard of stacks, have heard of queues, have heard of arrays, have heard of linked lists, and have done some classic questions around finding a loop in a linked list or something like that. But they're missing sort of the glue between the data structures, or maybe I want to say something more like what they're missing is what's important about each data structure, if that makes sense. So for example, one of the questions that I think you should be able to answer is, if I want to store a bunch of phone numbers, let's say, right? Should I use an array, or should I use a linked list? Or should I use a dictionary or hash set or whatever it's called in your language of choice? That's a question that you should be able to answer rigorously because you know the trade-offs of the different data structures. And I think that's something that a lot of people are missing.
I see. So it's a little bit around because sometimes we'll show people different tables of data structures and operations on it, like insert, search, sort, right? And it's but going from that into having a sense of how to answer this question is not necessarily always obvious, right?
Exactly. Yeah, to me that's the core difference is you can know, okay, this exists and these are its properties, but there's a little bit of a difference between knowing that and knowing this exists and here are its strengths, and here are the contexts where those strengths are helpful. And here are the contexts where those strengths aren't going to do you any favors, and you're going to want to use the strengths of another data structure.
And so here's something I always struggle with with getting people to practice for data structures and interview problems, because I feel like there's truly an infinite set of problems that can be asked, right? And I think that amongst programmers who have gone through the interview process a lot, we have some sense of that these questions have to live within a parameter set of being able to be something that can be answered in a set amount of time. Probably relying on, a set of library type data structures, library type algorithms. And so I'm curious, but it's very hard to convey that. It's very hard to tell someone this kind of problem that you see in the real world. You kind of have a good sense of whether or not you should know it for job interview process. Mm-hmm. So how have you InterviewCake broken that down into saying this is the progression of? Do you think about it like there's two ways I can think about it. One is here's a bunch of stuff, memorize kind of these parts, or here's the fundamental principles. If you learn these, you should be good in any place. And I think students freak out a little bit either approach.
Yeah, definitely. Yeah, so if I understand correctly, the question is it's terrifying being told you could be asked about anything in a coding interview. So how do you start to wrap your head around? Well, or I guess maybe, how do you know if you're ready or something like that, right? Or how do you know what the whole universe is of things that you need to prepare for? My answer to that is exactly sort of as you imply, is to notice that actually there's a small number of buckets of problem types. Mm-hmm. Where when I say problem type, it's not always evident in the problem which type it is. But the type is, I guess really I should say it's a solution type. So there are a few what I call algorithmic patterns that repeat over and over again. And the process of preparing for the coding interview, I think for a lot of people, and this was largely the insight with tutoring my friend that eventually that was the inspiration for InterviewCake, was that a lot of people, the way they prepare for the coding interview is they run a bunch of practice problems and slowly, subconsciously, they build up these patterns in their mind. They learn what I call the skill of algorithmic thinking.
Okay.
And for a lot of people, there's kind of this eureka moment where suddenly they see the patterns repeating. So it feels like in your first 5, 6, 7, 8 practice problems that you run, you keep having this moment of, oh my God, how do you even think of that, right? Okay, I get how that works, but how would I come up with that? And then there comes a moment after 12, 13 problems where you start going, oh yeah, I could do the same thing I did on this other problem. Oh yeah, that solution's like this other thing. Mm-hmm. And it starts to come full circle, and it kind of happens all at once, I think, for a lot of people. And so the idea behind InterviewCake actually is that instead of kind of throwing a bunch of problems at people and letting that categorization, that pattern matching process happen slowly and subconsciously, we give you the patterns from the beginning.
So can you give us an example of some of these? Because I think a lot of problems. Yeah. Can you maybe let me not. What are some of the examples of these patterns? Because I think that, for example, one example I use oftentimes. You mentioned cycles in a linked list, mm-hmm. and that the canonical solution to that is I think Floyd's where one is going faster than the other, right? And I'm the reason this is named after it's a difficult enough thing that they named it after somebody, which means that if you don't know that trick, you're not gonna identify it there in 30 minutes on a whiteboard with a stranger who's looking at you So is that a pattern where how do you think about that?
I would say it is, yeah. And look, there's an extent to which some of these are difficult. Mm-hmm. Right, they kind of there are insights that not everyone is going to pull out of nowhere, and so that's another thing to remember about the coding interview is that often your interviewer understands that, and she'll feed you little tidbits along the way, mm-hmm. To help sort of stoke that insight. But that being said, I would say there's a pattern there, and the pattern behind that solution is this idea of 2 pointers. Mm-hmm. It's actually something that you can see in the solution to a bunch of different coding interview problems. There's the classic problem about reversing a string in place. right?
I see.
Has the same idea of the solution ends up being that you have a pointer at the beginning and a pointer at the end, and you swap the values at those indices, and then you move those pointers towards each other.
Until they're equal or
Exactly.
or crossover or something.
Exactly.
Okay, and then so 2 pointers. So give me another example of a problem where I'm like, okay, I want to have like 2 pointers being the pattern that helps me identify the solution to a problem.
So you're saying another example?
Yeah,
of
besides
that?
the string, like,
Yeah.
or like how do I use 2 point? Because I really like this idea of having tools in my tool belt. Yeah, these patterns, tools in my tool belt, and I'm kind of like, if I memorize these, then I go to a problem, and I'm just going through this list of, and I think that is a little bit a definition of expertise, right? Having a bunch of these kind of in your tool belt, and being able to use them, kind of these models for thinking. But I'm curious, like, what is it? Maybe help our viewers with one more example of where like 2 pointers might apply.
Yeah. So for the 2 pointers one, I would say another example is, and this gets a little tricky because it's just a little hard to. Well, I don't know. We'll see if we can get there. There's one question where you're given 2 arrays of numbers, let's say, and they're sorted. They're both sorted, and you want to find, you want to return in a new array that has the numbers that are in both arrays,
Okay.
and also in sorted order. Number of different ways to do it. The best answer, it turns out, is to put a pointer at the beginning of each array and slowly move those pointers according to a set of rules.
I see.
And you can exploit the fact that the arrays are sorted to know that at any given point, like, oh, the number I'm on in this array is larger than the number I'm on in this array. So if this smaller number had been in this array, it would have been earlier. I would have already passed it. So I can confidently move this pointer forward.
Until I find a number that's greater than.
Exactly.
I see.
Exactly.
Okay, because that kind of reminds me of a pattern that we see in merge sort, where you have these 2 arrays and you're plucking them off, and then the interaction of, because they're sorted, it has all these nice properties of you know where you are in the. Okay, curious. So so that's kind of an example of that pattern being used somewhere else. What about another pattern? What's another common pattern
definitely.
that you see?
So the first one, so I have a lecture I sometimes give about this stuff that usually takes a couple hours, but I can try to kind of zip through some of the high notes. Yeah, maybe it's better to ground it in a problem. So let's say you, I'm trying to remember how I usually do this. Let's say you have an array of numbers and they're not sorted, and you want to find out what number appears the most times in the array. There are a number of different ways you can do that. I think this is a really interesting problem to illustrate. So your first guess, and you might immediately, if you've been doing this for a while, alarms might start going off when you talk about doing it this way. But a first guess might be, let's take the first item and see how many times it appears. So for that first item, loop through the whole array, count how many times it appears again, grab that count. If that's our greatest count so far, then that's our new most common item. Then move on to the next one, loop through the whole array to count it again. If that's our greatest count, that's our new most common item, right? And you continue through. So if you can picture the way you would actually do that, it's 2 nested loops. So that's going to be O of n squared time if you're comfortable with big O notation. But the important point there, and this is something we do a lot with InterviewCake, the important point there is to tease out like what that idea was. And to me, the idea behind that approach was to look at every possible answer and see if it's the correct answer.
Every possible. Sorry, I'm going to take some notes here because I'm fascinated. So every possible answer. What does it mean to be every possible answer in this case?
So this is how I like to define brute force.
Okay.
The idea behind a brute force algorithm is, again, this isn't necessarily the canonical definition, but this is what I like to say. The idea behind a brute force algorithm is to come up with every possible answer and check if it's the correct answer.
Okay.
So in this case, you're looking at every number in your array, and that's a possible answer for the most common number. So that's the first step, is figuring out how to come up with every possible answer. The second step is figure out how to check if it is the correct answer, if it is actually the most common number. Once you have those two things, you have a solution.
So I think that I like this idea a lot of just saying your first approach is, the first time you get this, you should try to just see the brute force approach. Like, what is the dumbest thing you could do to find this answer, right? And like, that usually it's a brute force approach. I mean, I think some students will often say, like, I struggle with that too, and I think that's reasonable. But what does that, is the idea to start from there and then optimize, or is the idea that that is kind of a method of thinking that you can then, like, if you're asking that question, should I even say, like, well, let's just, do this n squared way, just as a way to think about it? Or curious. Well, where are you going with that?
Yeah, it's debatable. In a real interview, I think you can probably, for that particular question, skip that solution, maybe. But the reason I teach it is because it's a helpful thought pattern, because there are better solutions to this one, but there are a lot of other problems. For dynamic programming problems, for example, it tends to be harder to come up with the better solution. But anytime you're coming up with a solution, you're helping yourself wrap your head around the problem, you're communicating with your interviewer, and you're making progress. So for harder problems, I think it's helpful to start with that solution. But the other, the kind of the point that I'm working towards with this problem is, that brute force solution, there's a pattern there. And you can take that same idea of come up with all possible solutions and see if they're the best solution or the final solution, right? Another common pattern that I teach is what I call greedy. And again, this isn't necessarily the canonical academic definition of a greedy algorithm, but I like to teach greedy as keep track of the best answer so far as you walk through the whole data set. And if you've successfully kept track of the best answer at every step, then when you reach the end, you have the best answer overall. Right? In this case, you can sort of do that. And usually the neat thing about a greedy algorithm is that it allows you to solve the problem in just one walk through the array. Right? And so if you start with that idea of, like, okay, can I do this greedily? Can I walk through the array once and keep track of the best answer so far? That's what kind of puts you in the headspace that allows you to come up with this idea of, like, well, okay, if I'm walking through in one pass and I'm keeping track of the most common number so far, I'm going to need to know, if I can ever look backwards, I'm going to need to keep track of how many times each number has appeared.
I see, okay.
So what data structure do I want to use to keep track of that stuff? The answer is probably a hash map. Could be an array, not to get too into the weeds, but that's a good example of the kind of thing where it's important to know the difference between an array and a hash map, and the fact that a hash map is built on top of an array. But anyway, if we call it a hash map, then you can keep track of, as you walk through the array, each number you see, you increment its count in the hash map. And that's all the bookkeeping that you need to do in order to know as you go which number has appeared the most times. But again, the important thing to me is not the particulars of those solutions to this problem, but what the pattern is behind them. Another way that I kind of teach the idea of the pattern is, what's the thing that if someone kind of like whispered it in your ear would like get you going?
Okay.
Does that make sense? Right?
Yeah, not really.
So a specific example is this idea of keep track of the best answer in one pass through the array. Right? It's sort of a summary of what the solution I just outlined is. And that's actually a summary of the solution to a lot of classic coding interview questions. And so if you just keep that as like a mantra on hand, or a tool, as the metaphor that you used, I think that's the kind of thing that takes your understanding of coding interview questions from like this black box of how do people come up with these blind insights into something where you're like, okay, I see that there's a process behind this. I see that there are a few different tools and a few different patterns for these algorithms.
That's interesting. I think that it would be, I think you're absolutely right that once people have a set of patterns, you still need to practice to apply the patterns to that, because that is very hard, but I think it's much harder to practice a lot and then reverse engineer the patterns. Like you start to see them, but almost intuitively, but it's nice to have words to them, right? Like just brute force and greedy and that's interesting. I think be curious to see if there's a good enumerated list of those patterns on InterviewCake, perhaps. Yeah. I'm curious. One question we do get a lot. You brought this up is big O, notation. Yeah. And I think that even for me as a day-to-day programmer, I think of it very intuitively, right? I'm like, okay, like nested for loops. I'm like, nested for loops is usually O of whatever, n squared or mn, or that you kind of have this general sense, and I have a sense of for example, but even like JavaScript objects, kind of our JavaScript objects and arrays, it's hard to, because like they behave differently under different situations. Like it's like we're kind of working on top of very high level tools. So I'm curious, like, do you recommend people? Do you think that's enough for people to get to these job interviews? Do you think they should know the underlying? Because I remember at some point studying like recurrence relations and like trying to figure this stuff out mathematically, but I couldn't do that in an interview these days.
Yeah, that's a good question. And recurrence relations are a good example. I think that be realistic about like where you are going into the process and how much time you have and stuff. I would guess for most folks coming out of a coding boot camp, you can probably skip recurrence relations. If I were preparing for coding interviews right now, I might review it because I'm pretty comfortable with most big O notation stuff, and I think all of us kind of have this list of things that we like hear sometimes, and like we're like, oh yeah, I should really learn.
I should
what that
learn
is.
that one day when I need it, but you never end up needing it really, right?
Yeah, it's rare. It can come up in the coding interview, so I would maybe review it, but I think you can pretty safely skip it for most folks. And I think that there's little o, there's big O, there's big theta, there's little theta in the academic world. You can pretty comfortably skip over all that stuff as an engineer preparing for coding interviews. For the most part, people just use big O notation.
And what do you think is a good set of things to study for big O? For someone who's, let's say you went through a coding boot camp and they never even mentioned this, right? But you know the data structures. What do you think is the kind of level that someone needs to get to do well? I mean, given that they're going in as applying as a kind of a, early developer. Yeah.
I would say we have some good resources on InterviewCake for this because it's a question I see a lot of folks struggle with. The basics of this is O of 1 time, this is O of n time, this is O of n squared time. As you said, understanding at a high level, if you're nesting 2 loops, that's probably going to be O of n squared. If you have just 1 loop, that's probably going to be O of n. But it's important to dig in a little bit more than that. The reason I say that is because I work with candidates all the time who will say, like, oh, it's just 1 line, so it's constant time. But that 1 line is array.sort. And it's important to understand that under the hood, a lot is going on there.
Yeah, that's interesting.
And in fact, sorting is a bit of a complicated case because the time cost is O of n log n. So it's n times log n. And I would say it's important to understand what that means, to understand that means n times log n, and what log n means, the fact that log n is less than n. So n log n is less than n squared, because it's n times log n, which is less than n, instead of n times n. But it's more than O of n.
Do you have good analogies for thinking about n log n and n squared?
Yeah, definitely. The way actually, it's been a minute since I've taught this, so hopefully I don't confuse myself. So the way I teach algorithms is log n. So usually in computer science, when we use logarithms, we're using log base 2. In other maths, it's more commonly in log base 10. In computer science, it's common in log base 2. So when you say log base 2 of n, what you're asking is, what power do I have to raise 2 to in order to get n? Right, so it's log base 2, so 2 is the base, right? So the question is, what's the exponent there to get that base?
I know, I'm like loading this from like deep storage into into RAM.
Yeah, we have some great stuff on it on InterviewCake. Okay, so what power do you have to raise 2 to get to n? And when you think about raising 2 to a power, that's also doubling, right? So another way of phrasing a question, what power do we have to raise 2 to get to n, is how many times, if I start with 1, how many times do I have to double before I get to n? Mm-hmm. And this is an important sort of, again, pattern to understand, because it actually comes up a lot in coding interview stuff, because binary trees, for example, involve a lot of doubling. In each tier in a binary tree, you have twice as many nodes. Yeah. In binary search, you're halving the size of the array at each step. A great way, so I actually like to teach binary search as a way of understanding log n, right? Because the question is, if you're doing a binary search in an array to try to find a number, what is your time cost? And the answer is, well, it's constant for each guess, right? And at each guess, you're grabbing the middle of the array and throwing out 1/2, and then you have a subarray of half the size, and then you do the same thing, right? So how many guesses do you have? Well, the answer is, how many times do I have to divide n in half to get to 1? Mm-hmm. That question is the same as how many times do I have to double 1 to get to n. It's just the other direction.
I see. Okay.
This is the same number of times. So the answer is log base 2 of n. Mm-hmm. Right? Because that's log base 2 of n. You can do the, if I had a whiteboard, I would like kind of do the algebra for you. Yeah. But you can see how log base 2 of n is asking that same question. How many times do you have to raise 2? What power do you have to raise 2 to get to n? And
so, like the intuition I always have with binary search is that like every time you go down, you make that constant choice down, you're in essence cutting off half the world, right? Exactly. It's like log base 2 of n, I'm almost like, to find that, to go down as deep as you can is your kind of, because you're cutting out every time, is your log base 2 of that whole end of that search set. It's I think, it's like one of those things, like many things I think that like after you see it, you kind of, okay, I kind of see it. But before, it's, this is how I feel about physics. People are always like, oh, once you do the equations, like general relativity makes sense. I'm like, I have a very hand-wavy, understanding of like relativity, but it's like, because I'm not doing the equations, but.
Yeah, I really believe that, and that's why I talked about my friend who I tutored on this stuff in the early days. She knew data structures and algorithms, but didn't quite. There was something missing, right? Mm-hmm. The sort of the thing of like, okay, but why does this data structure exist, right? And the answer is to like get around the weaknesses of other data structures, right? There's that extra level of rigor, or that level of like what does logarithm like really mean? Like, okay, I've like memorized a definition, but I don't have like the intuition behind it yet. I think all of that stuff is very learnable. Yeah. Unfortunately, people just don't teach it very well in a lot of cases.
I think it's like, because in those things where like once you see it, it's hard to unsee it. It's kind of hard to teach those things, right? Because you're like, oh, it's obvious, right? Like you're just navigating down the tree and you're cutting off half the thing, and people are like, what are you talking about? Definitely. I'm curious, like like, do you think there's maybe even I kind of think of this as like chemistry versus physics, right? Like chemistry, you have a lot of, I always did not like chemistry because I was like, it's a bunch of rules, and like you kind of memorize these rules, right? Like, what is like, valence electrons, like where do these numbers come from, right? Mm-hmm. And like you have to go down a level to physics to really understand why that is. Do you think there is like that same effect here where it's like, you kind of know all these data structures and they have these rules, but you have to know something below that, like hardware, memory, page tables. I mean, do you think that's important?
I agree. Yeah, I think that's a great analogy. Yeah, and I would maybe phrase the distinction as like rules versus facts, mm-hmm. and I would say that maybe chemistry has a lot of facts. Like, what's it called? Like the molar, like the mass of each thing, and so
Yeah,
it's just like
the only thing I'm thinking about right now is Avogadro's numbers, like
Yeah.
1 mole or something,
Right.
right?
There are a lot of constants. There's a periodic table. It's got all these numbers on
Yeah.
it. But physics is a
Right,
small
like
set of rules.
chemistry is like your constants file of your project.
Yeah. Right. So just import that, man.
Yeah.
Or like you can look that stuff up. But yeah, I think that's exactly true. That there's a and again, yeah, unfortunately, I think people teach linked lists often as here's the data structure and here are the properties. And I think there's a better way to do it. I think the better way is to say, here's an array, here's what it does, here's something you might like to do, and it's not going to work very well in an array. So how could you make a data structure where that would work well? And then you derive the idea of a linked list.
I see.
And now you understand what the properties are, and you understand like in what context you might want to use this thing.
Okay. And I think it's funny in JavaScript, the linked list feels more primordial than the array, because when you implement it, the array comes with all this stuff. But I think you're absolutely right. Like the array is the primordial computational kind of structure, right? Like just a bunch of space, a bunch of contiguous space.
Yeah, I think you have to, when you're learning this stuff, and I think this is difficult for folks who come out of coding boot camps, you have to really put down programming, if that makes sense. Like put down everything you know, not everything, but a lot of the things you know about the programming language that you're used to. And so in a 4-year computer science program at a university, this kind of stuff will be taught in C or Java, which a lot of coding boot camps don't teach, which I think is fine. I think you can have a great computer science education without learning C or Java. But the trade-off is that those high-level languages abstract away
So much of this.
a lot of the work.
Did you do a CS undergrad?
I did, yeah.
And then you were using C back then? Or Java?
No, so it was not that long ago. The intro course was in Java. These days they do it in Python.
Okay.
But we bounced around.
That's what I'm wondering. It's almost like because I did undergrad in electrical engineering, because I had this sense even back then that like I wanted to understand the whole stack, what was happening, and I still remember studying semiconductors, and there's this great course called NAND to Tetris, where you kind of study from a NAND gate all the way up to building an operating system, and I feel like that's kind of like something that almost everyone who's a programmer should do at some point in their career to understand the whole stack.
Definitely.
But I remember, I remember when our school went from C to Java, and I was like, it's kind of like, yes, the abstraction layer has moved forward, but now we'll have people who kind of never understand a lot of stuff.
Yeah, memory management.
Yeah.
Yeah, and I think that if you want to really understand data structures, you have to reach all the way down to the metal. You got to talk about bits. And it's not that hard. We have a great article on InterviewCake that starts with RAM and builds up all the core data structures with just bits in RAM. And it starts with the idea of RAM is a bunch of addressed sets of 8 bits. So in each of those little slots, there are 8 bits, and each of those slots has an address. And you look at that and you go like, wait, that's an array already, right? Mm-hmm. We have indices, and we can store a little thing at that index. And then, but you might start asking these questions of like, oh, but what if I want to store something bigger than 8 bits? Well, you can have 16 bits, and you'll just use 2 of those buckets for each of your address index. And you just have to do a little bit of math to figure out the 5th thing in your array is actually like 10 items down from the beginning of the array. And it just starts with that, and you build it up from there. But I'm a believer in like you have to get all the way down there and build up the stuff to really see the seams between the data structures.
Yeah, that's interesting. It's such a because I think even computer architecture itself is not built on some fundamental principle. It's like a ton of hacks upon hacks too, right? And so, yes, that it's like you're not going down to the fundamental. I mean, I think maybe the only thing fundamental is like the physics layer, like the semiconductors. But I'm curious if you have any advice for people who are struggling with recursion as a general idea. I feel like
Yeah.
I very rarely program. I very rarely, I guess now as we do more functional programming, it just in the kind of programming field in general, I'm starting to use recursion more, but it's something where I think a lot of problems love to use recursion as a way to solve it, but people struggle with that. So I'm curious if you have here's your to-do list, or here's like a checklist of things to do, or
Yeah, I would say so. This isn't everything, but this will for some people be that breakthrough moment. Is to remember. So again, we talked about algorithmic patterns. We talked about this idea that the idea behind brute force is you need 2 steps. Come up with all the possible solutions, and for each of them, check if it is the actual solution or the best solution. Right? If you know how to find all the possible solutions and you know how to check if they're the best solution, you have an answer. Similar thing with recursion. You have 2 things you need, a base case and a recursive case. So if you can come up with a base case, right, where you no longer have to do any work because the answer is obvious. In a lot of cases, it's like an empty array or something like that, right? You've gotten all the way down to nothing. And then you need a recursive case of like, well, if I had the answer for most of the other set except for one item, here's how I would build the answer overall. Once you have those 2 things, that's your function.
I see.
So the base case sits at the top, and the recursive case comes under it.
Because I think one thing people always, or I struggle with too, is that like not only, like the examples are, it's not that hard to figure out, okay, how do I make the step down, right? Like in factorial, how do I go n-1 or Fibonacci n-1? It's more like how do I, again, Fibonacci is like fib of n is equal to fib of n-1 plus fib of n-2, right? And like the plus between those two encodes the idea of Fibonacci itself, right? And so, like oftentimes, like figuring out the insight of how do you encode the subproblems back into the solving the main problem. That's the part I find like I struggle with the most. Like it's not that hard to say, okay, this is equal to some subcases of this, right? And the base case, I think the base case is dependent on the recursive nature of the recursive problem. So I'm curious if there's any. Because you have to understand the problem too, right? Like you have to understand what Fibonacci means to understand that.
Yeah, I think the part of the difficulty there, I think, comes from sort of giving yourself permission to be lazy, if that makes sense.
Yeah, I like that phrasing.
Like giving yourself permission to say, like, no, I know that I don't know the answer to fib of n-1. That's okay. Like, I'm going to trust that there are only 2 things I need here, right? How to come up with the answer if I have all of the smaller answers, and how to come up with the answer if my data set is in one of those base cases, if it's empty or just one item or just 2 items. Fibonacci gets a little tricky. You have a couple of edge cases. Otherwise, you might get index out of bounds errors. But that's the tricky part. I think you're right. Is really internalizing this idea of you don't have to know the answer to fib of n-1. The structure of recursion in general makes it so that that answer is computed recursively by going like, okay, well, I'll take fib of n-2, fib of n-3, et cetera, right, all the way down to the base case, and then it'll return all the way up. Yeah.
All right. I'm curious if you have other tips for people for the jobs for algorithmic questions. I mean, people freak out about this all the time, right?
Yeah.
Like, so we have a set of acronyms that we tell people to go through, a set of steps. I'm curious if you have thoughts on like, what do you do in that moment? What do you, and also, what do you do if you get stuck?
Yeah, definitely. So we have a new article that we actually just pushed out about how to get unstuck.
Okay.
Which folks should definitely check out. There's, I love the idea of codifying that set of steps as an acronym. We didn't quite get there for that piece, unfortunately. So I don't have like a handy thing, but I do have that list of tips. some of the things that come to mind right away are if you're stuck it depends where you're stuck. If you're stuck with coming up with something, you're in that moment where you've understood the problem and you've kind of tried a couple things and seen that they don't work, and you just don't have any kind of solution. First thing I would recommend is think about that brute force idea, right? So again, this is the kind of like someone whispering in your ear moment, right? Try saying to yourself, come up with every possible answer and test to see if it's the final answer or the correct answer or the best answer, right? So how can I come up with all possible answers? I know this is not going to be the most efficient, but this is going to help me to start somewhere. That can be really helpful. The biggest thing, even before that, I would say the biggest thing is drawing pictures.
Interesting. Okay.
By which I mean like draw out a sample input and solve the problem by hand. In fact, one story you could tell about how the algorithm design process works is there are 3 steps. The first is take a specific input and come up with the answer by hand. Right? The second step is teach your interviewer what process she could use to solve any problem by hand, right? Don't worry about how you do it in code, but just imagine if it was like a stack of paper and like how you would explain how this thing is done. Right?
Yeah.
And then the third step is articulate that process.
I see, like a pseudocode step of, like assuming you're working with someone who's like a complete automaton, and how that would work.
Yeah, and again, the idea is to kind of put down the end goal of writing code for long enough to just give yourself permission to just focus on like, okay, let me just find the answer for this one sample input. Yeah. Right? And then, okay, let me just see if I can explain how I did that. Right?
That's one thing so our acronym is Reacto, and I'll send you the article what it is, but C is code. And I'm like, so many people like want to get on the whiteboard and start going. I'm like, no, you gotta like think before you start writing. Like once you write the word function in your name, like you're kind of like bound to, you're kind of binding yourself as you go down that path. And so I definitely agree. Like don't draw it out. Our E is examples, right? Draw out the examples and solve them by hand. Yeah. I'm curious, like, have you seen this where the changing nature of interviews where people are, because I think there was a relatively, and this is a belief that I have, is that these problems don't really map to what a lot of people do. Sure. They much more represent a shared culture among programmers that we're like, I mean, it's like if I knew you were hacking on the Amiga and you like built a basic game, like I'm like, that's enough for me, right? Like this is the fact that you know this is like a test, right? And so, so I feel like these interviews are like culture tests much more than proficiency tests, which I think is not good, right? It's not good for the industry because it kind of very much limits our view into, it doesn't give us a diversity of experience into coming to the field. So I'm curious if so I think there's a growing reaction against these kind of interview problems, but I don't know if you think there's something better coming up, or if you've seen stuff that's new coming down the pipe.
Yeah, I'm pretty agnostic to that question. I can kind of see both sides. I think it's really interesting.
And I agree. I tell students, like, it doesn't matter what you think about it. If companies are doing it this way, you just gotta get good at it. Right? Yeah. It doesn't, for you as an interviewee, like, you can be religious about what you think, but it doesn't matter, right?
Yeah. I think that's kind of the main thing I focus on is like, this is the game, learn how to beat it. Yeah. If I were to, I don't spend a lot of time doing this, but if I were to think a little bit about like what the future of interviewing might be, one thing I might say is a strength of the current data structures and algorithms coding interview is that one thing it pokes pretty nicely is this question of, okay, are you the kind of engineer who can sling some code, right? Can come up with something that works? Or are you the kind of engineer who can come up with all of the different ways to do this and then carefully pick the best one? I think the coding interview, when done well, really effectively pokes that proficiency, at least in a specific problem space, which I think you're right is maybe not algorithm design is maybe not the most important problem space, or certainly not the only one. But I do think that there's something to that idea of figuring out, okay, is this the kind of person who knows enough just to come up to throw spaghetti at the wall until something works, or is this the kind of person who can see all of the different ways to do this?
Are you assigning a moral judgment to either of those? Because I can see a company that might value both.
Yeah, certainly, and I think that they're
Or that might value one. No, so I'm thinking like if I'm a startup, I don't necessarily care that someone has the best solution if this person is like shipping stuff constantly. But if I'm like, like about the IPO of my company and I need engineers to scale up my stuff, I don't want people who are doing the best, right? So I'm curious if you.
I think you're right. Depending on the engineering culture and the phase of the company, you may have different sort of goals around how correctly done everything needs to be the first time. And I think that I think I can confidently say that like ultimately you're a stronger engineer if you can do the latter thing, if you can come up with all of the solutions and then pick the best one.
I see. Okay.
I would say that there are two parts of that, what I like to call the knowledge piece and the wisdom piece, right?
Yeah.
So it's the knowledge piece of knowing here are all the different ways to solve this, and here is the one that is the most optimal in terms of runtime, right? And then there's a wisdom piece of understanding like, okay, that is true, but this other solution is going to take a fifth of the time, and it's going to be fine, and this doesn't have to be performant right now, so I'll just do that, right? But that was a careful decision, not just like, oh, okay, I tried a bunch of different ways until one of them worked.
Yeah.
I think that with experience, you can become that latter type of engineer, and I think that at least for more senior engineers, that's something that the coding interview ought to be able to test for.
I see. What about project-based interviews where people are kind of having you do, anywhere from 4 to 8 hours of work? Have you seen that more, or do you think that is something that is going in a good direction, or too easy to game?
Yeah, I think it's interesting. I don't know that much about how companies do it.
Okay.
Because I understand there are a few different ways to do it. You can give someone a take-home assignment. There are also some companies that will just bring you in for a day, basically like hire you as a contractor for a day, or even for a week, or even for a month. There are a lot of different ways to do it. I think that stuff is really interesting.
I want to ask you some time about InterviewCake. So I'm someone who's just graduated from a coding boot camp. I'm looking at InterviewCake. I'm about to go into interviews. Like, how do I know if InterviewCake is the right, or what makes InterviewCake the right product for me to like kind of invest my time and money into? Yeah,
the thing I would say is definitely check out other stuff. See what's the right fit for you. The thing that we're really focused on with InterviewCake is teaching.
Okay.
So there are a lot of other resources that are good as banks of practice problems, and what you might find that a lot of them are missing is explanations for like, okay, not just here is the solution and here's why it works, but here's the thought pattern that you should be able to have to come up with that solution. And here's the underlying algorithmic pattern that we can pull out of that solution that we can then use to solve other problems.
I see. You're saying like, I think at the worst, all the code bank or all the question bank has is like a solution, right? And you're kind of like deriving yourself. But when you say teach, like, are you like maybe walk me through like how is someone learning inside the InterviewCake platform?
Yeah, definitely. So what we built with InterviewCake is a flow that mimics an actual coding interview.
Okay.
If we wanted to be buzzy, we would maybe call it like an artificial interviewer. It's not really what it is.
That would like quadruple your evaluation overnight,
yeah,
I'm sure.
It should, right? We could go right to Sand Hill Road.
Yeah.
So really what it is like a choose your own adventure.
Okay.
So you get the problem statement, and then you get these two buttons. I have an answer, or tell me more.
Okay.
Little interesting backstory, the tell me more button, used to be, I need a hint.
Okay.
And we changed it because we found that people weren't pressing it enough, because people don't like saying I need a hint feels like giving up.
Interesting. Do you recommend that in an interview? If I don't understand what someone's asking me, it's like, I'm not going to say I'm stuck or I need a hint. I'm just like, tell me more.
Yeah, I wouldn't recommend that necessarily, but that is what will happen naturally in a coding interview. Your interviewer will see that
oh, I see, okay.
that you're struggling, or even you'll start going down a path. We have some great articles that we just launched about this kind of stuff on the website. Sometimes your interviewer will see you going down a path, and they'll interrupt and say, like, I see where you're going. There's a solution there, but it actually ends up being more complicated than you think.
Okay.
Let's think about it this way instead, right? So this is something that I think is really important to understand about the coding interview, is that your interviewer in a lot of cases actually expects that they're going to have to feed you a couple things.
Mm-hmm.
And what they want is to see you take that thing and run with it.
Let me take a quick aside. If you know the answer to the question that someone's asking you, how do you play that?
I would say you should say.
You should say it.
You should
Okay.
tell your interviewer. Yeah.
People ask me, like, should I ham it up and be like, well, or should I just kind of go through it normally? Because then people are always afraid of it. It's like, oh, you know this. Let me really like wallop you with a hard question.
Yeah. It's not uncommon for an interviewer to say, like, okay, cool, well, let's do it anyway.
Okay.
But yeah, so some might come back with something harder. I guess it's a bit of a risk. The thing I would say is most of us are not as good of actors as we think we are. And,
That's so true.
And so you're running a serious risk when you try.
Integrity risk, yeah.
Yeah, because now, if your interviewer figures out that you've seen this problem before, and she might not tell you that she's figured it out, right?
Yeah.
She might just quietly note it. But now you're dishonest, right?
Okay.
I mean, that's.
I like that answer. Yeah, just let them know, and that very often they will just have you go through it anyway.
Yeah.
Now I guess the other question, like in the 2x2 matrix, is if you don't know it, would you ever recommend just saying? I've seen this. It's like.
Yeah.
I saw a funny talk. It was like programmers, the known unknowns, right?
Yeah,
It's like, and you never feel good if you're like, don't explore all parts of that
Yeah.
quadrangle. So I'm like, the other part of that quadrangle is I don't know the answer, but then I posture that I do know it. That might get you through it too.
Yeah, there might, I don't know, if I had to reach, there may be a way in which like that fake it till you make it attitude would give you some confidence.
Yeah, that's and this is something that I love to talk to students about. It's like sometimes if we reverse engineer success and then we do the things that people do who are successful, it creates a success. So I'm curious, like, if you have analytics on people who do InterviewCake and do well, what are they doing in InterviewCake? Like, are they spend an hour a day, 10 minutes a day, once a week? Like, what do the analytics look like for the people who are successful?
Yeah, that's a good question. Unfortunately, unlike a school like Full Stack, we're pretty low touch with our users. We invite people to email us, and a lot of people do take us up on it.
Mm-hmm.
A lot of people also don't.
Okay.
So we don't always know how well it's worked out for people. We have a money-back guarantee where it's actually a get-the-job guarantee. So if you don't get the job, you can ask for a refund. So we know when it doesn't work out for those folks. So yeah, I don't have as much insight about that as I would like.
Let's maybe we can work at the other way. Look at the negative case. The people who it doesn't work out for, what are they doing?
For the most part, it's that they didn't use it.
They didn't use it. Okay.
Yeah.
That's true. And I often think with oftentimes it doesn't matter what you do as long as you do something. Like weight loss. I always think you can pick any one. There's 1,000 weight loss methods, right? They probably all work if you stick with them,
mm-hmm.
right? But it's hard to stick with things, right? That's the challenge.
Yeah.
All right, cool. Any other things you'd like to share about InterviewCake? Like, is it how long does it take to get through it? What is the
Yeah, so there are, I think the latest number is 48 questions on the website. I might be wrong about that. I think it's 48. And so, these are hard questions. These are real coding interview questions that might come out of an interview that might be an hour long. So if you assume that each question is an hour, this is what I like to tell people. Figure out how much time every day you want to spend on coding interview prep, and actually put it on your calendar. Don't just say, I endeavor to do an hour every day. Pick which hour of every day and put it on your calendar. If it's before bed or if it's in the morning or whatever, right? And then if it's an hour a day, you figure one problem, maybe two problems a day. We have a solid month of content for you.
I see.
But I think the place a lot of people get tripped up is like, oh, well, I don't have a month. For some folks. Some folks do.
I have like a week before my interview at
Google.
Google.
In fact, we actually get a lot of people who are like, my Google interview's on Monday. And this is actually something on the kind of company sales side, we're trying to figure out, like, we need to have something to sell to those people. But actually, the way that we've set up the course...
Interesting, because like I remember when I was doing the SAT, I bought all the books, and like it was about a week out, and I went to the store, and it was like, there was literally a book called "You're Screwed, You're a Week Out from the SAT Test, buy this book," right? Like you need that product.
Yeah, definitely. But the secret is that our product actually was carefully designed to already be that product.
Okay.
What I mean by that is the questions are ordered, so you might notice on our all questions page, it's not broken up into topics the way a lot of other resources are. It's actually just one linear list of questions. And you'll notice that they're very carefully ordered in a couple of ways. The first is that you'll see patterns repeat quickly so that you're really kind of hammering them in. But the second is that the most important patterns are at the beginning of the course. So basically, the course is carefully designed so that however far you have time to get in the course, that will have been the best use of that time.
Is there any like pedagogical research or methods that you like that are part of this? Like the one I always think about is like spaced repetition, right?
People love spaced repetition. Yeah. I'm a huge education theory nerd. We don't use spaced repetition. We could, but I think a lot more. I think spaced repetition is a good example of the kind of thing where that's good for trivia. Right, we talked about facts versus rules, right? Chemistry versus physics, right? Spaced repetition is really good for that, but we don't focus on that. We focus on the rules kind of stuff.
Okay.
And so instead, I don't know. There aren't any good like vocab words for the kind of stuff that we do, but I can say a big inspiration is a guy named Brett Victor. Have you heard of him?
Yeah.
He has a website called Worry Dream. He has a bunch of great lectures that he does. And he talks a lot. I actually was really fortunate. I got to demo the product to him in the early days.
Okay.
And he like tore it to shreds. He came up with all the things we're doing wrong. But he talks a lot about how to give people the right picture in their heads so that they can understand what the heck is going on with the system. And that's something that we're really focused on.
I see. Do you build visualizations of different things? Because I mean, every time I see one of those like data structure visualizations or algorithm visualizations, I mean, I'm blown away, but they're very time intensive to create. So of course you do.
So we do we do that sort of. So a couple things about that. The first is. It's a core philosophy of InterviewCake that our time is less valuable than our users' time. There are all kinds of ways that you can see, not to point fingers, but some products in our space, but also all kinds of products in all kinds of different spaces where you can see, and I hate this so much, the way that most companies do customer service is you can see all the choices they've made to save them time and cost you time. And it's truly, you can see him getting a little worked up. It's truly infuriating to me. Every time you get the thing of you call and there's an automated voice thing and you have to punch in numbers to articulate what you want, it would be much faster for an operator to be told what you want and then put you in the right department, but they're trying to save time and money. And at the expense of your time.
That's true. Like they're pushing costs down to the users rather than.
Exactly.
But what are examples of this? Because I feel like software scales so well that oftentimes like this problem doesn't. Like, give me an example of this in software.
Well, and content scales well, and so that's why our business works, I think, is because, we get crazy obsessive about the best way to really help people fully wrap their heads around logarithms, give them a picture in their heads so that they understand what the heck is going on, what the heck a logarithm means. And then we really invest in that. And we dig into, first of all, we revise 1 million times the stuff that we write. And we use a lot of diagrams. And that's a good example of a case where those are very labor intensive to build. And we go through a lot of revisions with them.
And are these diagrams things that you've drawn out in video or like actual software diagrams in the question or?
So I'm thinking right now about articles on the site, but some of the questions also have diagrams. They're just SVGs that we've drawn, and they don't move around. They're not animations. There are some animations that was something I got really excited about in the early days, and I thought that would be a big part of InterviewCake. But actually, this is some feedback I got from Brett Victor, is that the problem with animations is that the user can no longer control the pacing.
I thought he was big on animations, but like he has a lot of like sliders and.
But it's a subtle but important difference, right? Because you're moving the slider. I guess you could call that an animation, as opposed to a video.
But like interactive animations, that just makes it even harder to kind of create that content at scale. In fact, I feel like
that's right.
There's probably like 10 algorithm visualization sites on the internet where you think there'd be like billions of them, right?
Yes.
But that's interesting. Like I think I've seen continuous attempts at making, like the one I thought was really interesting was Python Tutor. Have you seen that one?
Yeah, so they're programmatically building the data structure.
Yeah, and like
the code is
the
created.
visualization of the data structure. But it's hard to create something general because, I mean, his research was like, can I take code and then output what's happening kind of at the memory level, and then show the connections between it.
Yeah, really cool project.
Yeah, but it's hard to you can very easily create something that the visualization is totally messed up, right?
Yeah, and that's a good. I love nerding out about this stuff. I think about this stuff a lot. And one of the decisions we've kind of made as a company is that. When you're building a general purpose tool like that, you're inevitably making a little bit of a trade-off where in order to do it programmatically for any code, for any specific piece of code, you might not be outputting something that is the easiest possible thing to understand or the prettiest possible thing. Does that make sense? Because like your logic behind how you build a graph diagram, for example, has to be data-driven, and so inevitably there are going to be some edge cases where like your tree gets a little squished or it's a little confusing or something. You can try to smooth that out over time. But at a high level, if you pick a specific piece of code and decide, I'm going to really just illustrate this, you can fully control the process and you can hand draw the best possible diagram. So we've moved more in that direction.
I see.
But for a while, we thought about trying to actually build a system like that.
Like a generalized visualization of the.
Yeah.
I'm curious. I think now with like augmented reality and VR, you can work with canvases that are much more. I'm just thinking of the old movies where like they were having a file system that was like file cabinets inside VR space, right? Like I mean, clearly.
Yeah, that scene in Jurassic Park.
Yes,
where,
yes, right.
The
It's
girl
like.
says this is a Unix system.
And so maybe we'll see things that are more generalized in that space now that we can have the goggles that we can navigate much larger spaces than. But that's something that I thought about too. That it's definitely a compromise between specificity and generality, and then specificity usually it's just so much better to get something there.
Yeah.
I'm curious if there's other stuff that other stuff in this, because you know the space so well. Other stuff in this space that you like in terms of interview prep and practice.
Yeah. Well, one thing that we're looking at right now is mock interviews.
Okay.
it seems pretty clear that we can get better and better. We can get really close to the best possible lesson on binary search or whatever, right? But there's just no substitute for doing real interviews.
Yeah.
So I would definitely recommend people do that. And if you can do that with a buddy, that's great. But there are some really cool services out there that offer it. I know I'm going to forget some, but the ones that come to mind right now are interviewing.io.
Okay.
Pramp is another one.
It's an interesting add-on to like I'm practicing myself to practicing somebody else. Okay.
Yeah.
Awesome.
Those are the two that are coming to mind right now.
Okay. All right, Parker, this is awesome. I'll definitely put some links to InterviewCake and the things you mentioned in the video notes. And I think this is really helpful to kind of get an expert's thought on this process, because I think it's so broad that it's hard to navigate yourself. So thank you so much.
Yeah, thank you.
Awesome. All right, that was very